Ever wondered how a tiny sunflower seed becomes the cooking oil in your kitchen? The transformation is remarkable. While the average sunflower produces 1,000 seeds, it takes roughly 500 flowers to create just one bottle of oil. In this factory tour, you'll see the entire production process from field to bottle. The precision machinery that transforms these tiny seeds into golden liquid works with mesmerizing accuracy and efficiency. And you're about to witness every fascinating step of this journey. Let's dive into the world of sunflower oil production. If you enjoyed this peek into the process, don't forget to hit like and subscribe for more amazing factory tours and behind-the-scenes looks. Hit the bell icon so you never miss an update. Did you know farmers don't just plant any sunflower variety for oil production? Those massive golden fields you see aren't just pretty to look at. They're carefully cultivated cash crops selected for maximum oil yield. Take a look at these vast golden oceans of sunflowers stretching to the horizon. Farmers are incredibly picky about which varieties they plant. They select specific high-oil hybrids that produce seeds containing up to 50% oil by weight. Standard varieties only give 30% oil, making a huge difference when harvesting thousands of acres. Growing these oil-rich sunflowers requires careful attention. These plants demand well-drained, slightly acidic soil with balanced nutrients. Farmers regularly test their soil, creating the perfect growing environment. Too much nitrogen produces tall plants with fewer seeds, while too little potassium significantly reduces oil content. Check out how the farmers walk through these vast canvases of light throughout the growing season. They're examining the backs of the sunflower heads, waiting for that perfect yellow-brown color, signaling maximum oil content. Harvest timing is critical. Too early means losing thousands of gallons of potential oil. Too late risks losing the crop to birds or rot. The unsung heroes of this process are these specialized harvesting machines. Look at how they cut the entire flower head and separate the seeds in one continuous operation, collecting thousands of seeds per minute. They're calibrated specifically for sunflower harvesting, with special attachments to catch seeds that might otherwise fall to the ground. Weather becomes the farmer's biggest concern during harvest. See those farmers checking their weather apps constantly. A sudden rainstorm can be disastrous, causing mold or fermentation that ruins oil quality. High winds can knock mature heads to the ground, making mechanical harvesting impossible. Once harvested, the seeds are quickly transported to specialized storage facilities. With carefully controlled temperature and humidity, improper storage increases fatty acid content, making the oil more difficult to refine later. Farmers select high oleic varieties for oil production, specially bred sunflowers producing oil with more monounsaturated fats and better stability when heated. They also prioritize disease-resistant varieties, since a single fungal infection can devastate an entire field's yield. See these farmers examining seed catalog data. They're analyzing the breakdown of fatty acids that determine how the oil performs in different cooking applications. Some varieties excel in high-heat cooking, while others offer mild flavor for cold applications like salad dressings. Now these truckloads of tiny black seeds are arriving at the processing facility. Each truck carries the harvest from several acres, about 1,500 pounds of seeds per acre. It's hard to believe these hard little seeds will transform into the golden cooking oil you use in your kitchen. Those truckloads of seeds may look identical to the untrained eye, but the reality is far more complex. When seeds arrive at the factory gates, they're about to face a ruthless selection process, where only the truly elite make it through. What if I told you that up to 5% of what arrives isn't even seed at all? Hidden among those tiny black kernels are stones, twigs, and various debris that would wreak havoc on both machinery and oil quality. Think of these sorting systems as high-tech bouncers at an exclusive oil production club. Only the finest seeds get past the velvet rope. Check out those massive vibrating screens creating hypnotic wave-like motions. These industrial-sized sieves catch larger debris while allowing properly sized seeds to fall through, while smaller screens filter out the undersized runts that wouldn't yield much oil anyway. Look at those powerful air separators creating calibrated currents that blow away lightweight materials like dust and hull fragments. It's a precision version of traditional grain winnowing that ancient farmers would marvel at. Meanwhile, optical sorting machines perform split-second quality checks on thousands of seeds per minute. High-speed cameras capture detailed images, while sophisticated software makes instantaneous accept-reject decisions. When a discolored seed is spotted, whoosh, a perfectly timed air puff blasts it away with over 95% accuracy, all happening faster than you can blink. Moisture testing represents another critical checkpoint. Seeds with too much moisture risk developing mold during storage, ruining entire batches. Seeds that are too dry tend to break during processing, reducing yield. Technicians regularly test samples to ensure that perfect moisture sweet spot before moving forward. They're also analyzing oil percentage to determine if seeds will produce enough oil to make processing worthwhile. Using specialized equipment, they precisely measure how much oil each batch contains, rejecting deliveries that don't meet minimum standards. This meticulous approach exists for good reason. Poor quality seeds reduce yield and actively harm the final product. Seeds with high levels of free fatty acids or excessive moisture can produce rancid oil that would spoil before reaching store shelves. What makes this system fascinating is how it combines multiple technologies with human expertise. Physical properties like size and weight help with initial sorting. Visual characteristics enable high-speed inspection. Some advanced facilities even use X-ray technology to detect hidden foreign materials inside the seeds themselves. It's a multi-sensory approach that mimics human sorting, but at industrial scale and speed, processing tons of seeds per hour while maintaining incredible accuracy. With human technicians and sophisticated machines working in perfect harmony, only the highest quality seeds make the cut. Having passed through this gauntlet of quality control checkpoints, these elite seeds move forward to the extraction stage, ready to release their liquid gold. Well, now that we have the finest seeds ready, let's examine the crucial fork in the road that explains why some sunflower oil costs 3 times more than others. The extraction method chosen here creates a fundamental divide in the sunflower oil world, affecting everything from taste to price point. Which process better preserves nature's best? Tradition or technology? Take a look at this first production line where cold pressing happens. These massive steel presses crush seeds without applying any heat, keeping temperatures below 40 degrees Celsius. This careful approach preserves the natural flavor profile and nutrient content that would otherwise be destroyed at higher temperatures. Notice how slowly the golden liquid drips from these presses. It's almost mesmerizing to watch. This method is deliberately gentle, and while that's great for quality, it comes with a significant trade-off. From every 100 kilograms of seeds, cold pressing typically yields only about 38 liters of oil, leaving a substantial portion trapped in the seed cake. The oil coming directly from this process carries a rich, buttery, nutty aroma that envelops the workshop. You can actually smell the essence of fresh sunflower seeds in the air around these presses. This distinctive character is what you're paying for when you see cold pressed prominently displayed on that premium bottle. But over on the other side of the factory, efficiency takes center stage. Check out this industrial scale solvent extraction system. The crushed seeds here are washed with hexane, a chemical solvent that dissolves oil remarkably effectively. This process recovers up to 99% of the available oil, leaving virtually nothing behind. Look at how the hexane oil mixture flows into these massive evaporators. The system separates the solvent from the oil through controlled heating, with the hexane collected and recycled back into the system for the next batch of seeds. The contrast between these methods highlights a choice we all make daily: quality versus practicality. While cold pressing captures the essence of sunflowers at the expense of yield, solvent extraction maximizes output but sacrifices some natural character. The solvent extracted oil requires more extensive refining to ensure no hexane remains in the final product. This process strips away some of the distinctive flavor compounds and natural nutrients that cold pressing preserves. The result is a more neutral tasting oil, lacking the character of its cold pressed counterpart. This fundamental production divide explains much of the price difference at the grocery store. The cold pressed oils, with their labor intensive process and lower yields, command premium prices, often $15 or more per bottle. Meanwhile, the efficiently produced solvent extracted oils can sell for as little as $5, making them accessible for everyday cooking. Each method serves a different need. For high heat cooking, where oil is simply a medium rather than a flavor contributor, the refined solvent extracted oils make perfect sense. But for applications where you want the oil itself to add character, like dressings or finishing dishes, the premium cold-pressed versions offer noticeable benefits. Watch how these separate production streams eventually lead to different bottling lines. The cold-pressed oils often go into smaller, darker bottles that protect their delicate compounds from light degradation. The solvent-extracted oils typically flow into larger, clear containers designed for value-conscious consumers. With those separate production streams flowing to different bottles, you might think we're finished. But that dark liquid moving through these industrial pipes would shock most home cooks. Look at this sample of crude oil fresh from extraction. Notice its murky appearance and deep brown color. It bears almost no resemblance to the crystal clear golden liquid you're used to seeing on store shelves. This raw oil is nature's unfiltered bounty, a primordial soup of compounds that would make your kitchen experiments go terribly wrong. Without processing, it quickly turns rancid, develops off flavors, and smokes excessively when heated. The transformation from crude to finished product requires an ingenious 5-stage refining process that balances purity with nutrition, much like a sculptor carefully chiseling away impurities from a rough block of stone. Our refining journey begins at the degumming and neutralization stages. Watch as technicians add measured amounts of water or acid to bind with phospholipids, those pesky gums that make oil cloudy and unstable. The mixture gently agitates in these large tanks, allowing water-loving gums to separate and settle at the bottom. Then comes the chemistry. Operators add caustic soda to the oil, creating a reaction similar to homemade soap making. This binds with free fatty acids, forming compounds that wash away substances that would cause spoilage. Look at this next phase, bleaching. Despite its name, no chemical bleach is involved. The oil flows through tall columns packed with activated clay that acts like a magnet for pigments and impurities. You can literally see the transformation happening. The amber liquid gradually lightens to that familiar golden hue we recognize from store shelves. Moving along, we reach the winterization chambers. This clever process explains why your sunflower oil stays clear in the refrigerator, unlike olive oil, which often becomes cloudy when chilled. In these cooling units, the oil chills to specific temperatures that crystallize naturally, occurring waxes without solidifying the oil itself. These wax crystals get filtered out, ensuring your oil remains clear even when cold. The final refinement happens in these impressive deodorization towers. Oil enters at the bottom, heats under vacuum conditions, and steam injects through it. This gentle distillation strips away volatile compounds responsible for unwanted odors or flavors, resulting in a neutral-tasting oil perfect for cooking. Throughout this process, manufacturers walk a tightrope, remove too few impurities, and the oil won't be stable enough for commercial distribution. Remove too many, and you risk stripping away beneficial nutrients. Modern refineries use precise computer controls to monitor every variable from temperature to pressure, maintaining that delicate balance. These different outlet pipes represent varying degrees of refinement for different markets. Some oils undergo minimal processing to retain nutrients but have shorter shelf lives, while others receive full refinement for maximum stability and neutral flavor. Each stage of this sophisticated transformation targets specific impurities while preserving nutritional integrity, turning that dark, cloudy crude into the stable, clear golden liquid consumers expect. That beautiful golden liquid might look perfect after refinement, but appearances can be deceiving. Behind the scenes, each batch of sunflower oil enters a scientific gauntlet where a single failed test can send thousands of gallons back for reprocessing. Let's step into the quality control laboratory where the real guardians of your cooking oil work their magic. Inside these pristine labs, technicians in white coats systematically analyze samples from every production batch. Their workstations feature specialized instruments measuring qualities invisible to the naked eye. They conduct a series of chemical composition tests, peroxide values, free fatty acids, and color analysis, which together determine if an oil will remain stable on your shelf. We're looking for early signs of oxidation that affect shelf life, explains a technician as she carefully pipettes oil into a testing chamber. High peroxide values or excessive free fatty acids will flag a batch for reprocessing immediately. These compounds naturally occur in oils, but excessive amounts can affect flavor and stability. The color testing area uses spectrophotometers that break down the oil's color into exact measurements of yellow and red values. An oil that's too dark might indicate improper refining or contamination issues, notes a lab worker, adjusting the machine for the next sample. Check out one of the more dramatic tests, the smoke point analysis. A technician heats a small oil sample, watching intently as the temperature display climbs steadily past 400 degrees Fahrenheit. High-quality refined sunflower oil should withstand temperatures over 450 degrees Fahrenheit before smoking, she explains without taking her eyes off the equipment. Commercial kitchens rely on this information for deep frying applications. The sensory evaluation station might surprise you. Here, specially trained technicians actually taste and smell oil samples. With small blue cups in hand, they swirl, sniff, and sample the oil, making detailed notes about its flavor profile. Machine testing is essential, but human evaluation catches things instruments can't detect, says the sensory lead. We catch hints of rancidity, metallic notes, or other flavor defects that would be unacceptable to consumers. In a separate temperature-controlled room, stability testing takes place. Small vials of oil sit in specialized ovens that accelerate oxidation processes. We're essentially simulating time itself, explains the stability testing manager. These accelerated aging tests compress months of shelf life into days, revealing how quickly quality deteriorates under normal storage conditions. The contamination screening is equally rigorous. Specialized equipment detects trace amounts of pesticide residues, heavy metals, and microbiological activity. A digital wall monitor displays results in real time as each batch undergoes more than 15 different laboratory tests. Every parameter must meet strict regulatory thresholds. The lab director points to the monitor. When a batch fails even a single test, it's immediately flagged in the system. Sometimes minor adjustments can bring it back into specification, but other times entire batches must return for complete reprocessing. Costly but absolutely necessary for maintaining quality standards. Once the oil passes those rigorous quality tests, it's ready for the final crucial phase, packaging. With perfection verified, the journey continues as the bottling line springs to life with an almost hypnotic rhythm. Like a well-rehearsed orchestra, these precision machines work in perfect harmony, filling, capping, and labeling up to 22,000 bottles per hour. That's over 6 bottles every second disappearing down the conveyor belt. Look at the beginning of the line, where the empty bottles arrive. Each bottle gets a quick blast of compressed air to remove any dust or particles that might contaminate the oil. This critical step ensures even microscopic contaminants can't compromise the oil's quality, a standard the food industry demands. Now watch as the bottles move to the filling station, where precision nozzles dispense exactly the right amount of oil into each container. The machinery adjusts automatically for different bottle sizes, from small specialty containers to large family-sized jugs. The golden liquid flows at carefully controlled rates to prevent splashing or introducing air, one of oil's greatest enemies. Notice how premium oils are directed to dark green or amber glass bottles, while standard refined oils go into clear PET containers. This color difference isn't just marketing, it's science in action. The darker bottles shield against ultraviolet light, which can trigger oxidation reactions that degrade oil quality and significantly reduce shelf life. At the capping station, specialized machines apply airtight caps with tamper-evident seals. These create a crucial barrier against oxygen, another of oil's natural enemies. Even tiny amounts of air exposure can start chemical reactions that create that unpleasant rancid smell and taste that ruins cooking oil. The bottles race through labeling machines that apply information-packed stickers with remarkable precision. Beyond brand names and logos, these labels contain production dates, batch numbers, and expiration dates. This traceability system means manufacturers can quickly identify exactly when and where any specific bottle was produced if quality issues arise. Check out the final phase, where filled bottles are grouped into cardboard cases, stacked onto pallets, and shrink-wrapped for stability. These pallets go to specially designed facilities with controlled temperature. Oil quality is surprisingly sensitive to temperature fluctuations, so these warehouses maintain consistent conditions that prevent degradation while awaiting distribution. You might have noticed something interesting when shopping. Some sunflower oils look completely transparent, while others have a deeper golden hue or slight cloudiness. This visual difference comes down to the level of refining and filtering. Crystal clear oils have undergone extensive refining processes that remove virtually all particulates and natural compounds. Meanwhile, cold-pressed or less refined oils retain more of those natural elements. giving them that distinctive cloudy appearance and deeper color. This visual difference isn't just about looks, it reflects a fundamental difference in what you're getting. The crystal clear oils offer remarkable consistency and stability, especially for high heat cooking. Those cloudier oils might look less perfect, but often contain more of the natural compounds and nutrients that get filtered out during intensive refining. As our journey through the sunflower oil production process concludes, we see an industry innovating sustainably. Manufacturers are developing drought-resistant varieties that require fewer resources, while significantly reducing pesticide dependence compared to other oil crops. These fields don't just produce oil, they create habitats supporting pollinators and enhancing biodiversity. The extraction technology advances and climate-adapted sunflower varieties represent remarkable achievements in agricultural science and food technology. Whether you choose cold-pressed varieties for their rich flavor or refined oils for their versatility, you're participating in an industry increasingly balancing quality with environmental responsibility. Next time you cook with sunflower oil, appreciate the careful innovation behind this everyday ingredient that connects agricultural ingenuity to your kitchen.